Hello grade 11s, welcome to this listen to the solutions to exercise 6. So I'm just going to take you through those selected questions. In the first one, find the sum of each of the following infinite geometric series. So find the sum, so let's check. So and it goes on indefinitely. So the first term here is 2, and the ratio, what's the ratio there, is equal to a third. Remember, we can only find the sum of a geometric sequence, and if it converges when the ratio is between minus 1 and 1. So the sum of infinite number of terms, remember, it's a over 1 minus r. So therefore, that is a is equal to 2, 1 minus a third. So it's the sum of 2 divided by 2 thirds. And therefore, that then is going to equal to 6 divided by 2, and that is equal to 3. Right. So the next question, that was question B. So find the sum. So the first term is minus 64. The ratio now is equal to negative a half, right? The sign changes every other term. 32 divided by minus 64 is minus a half. Minus 16 divided by 32 is minus a half. So we're going to find the sum, then a over 1 minus the ratio. So the sum of infinite number of terms. A is equal to negative 64. 1 minus the ratio of minus a half. So that means that it's negative 64 over 1 plus a half is 1.5. That's 3 over 2, right? So that means it is negative 128 divided by 3, and whatever that is on your calculator. Question 2a. So you've now been presented with a sigma question. Sigma means sum. So what we first need to work out the first 3 terms of that general sequence. So therefore, it's term 1, then we've got term 2, then we've got term 3, and so on. So term 1 is 8 times by 2, negative 2m, right? And then, of course, the same thing there in term 2, 2 times by negative 2m, and term 3, 8 times by 2, negative 2m, and we go on forever and ever, infinity and beyond. So where do we start? If the counter starts at 1 and it goes up, right? So therefore, that is equal to 8 times by 2 to the negative 2 plus by 8 times by 2 to the negative 4 plus by 8 times by 2 to the negative 6. And then that is equal to 8 over 2 to the 2 plus 8 over 2 to the 4 plus 8 over 2 to the 6 plus, and that then becomes 8 over 4 plus 8 over 16 plus 8 over 64, and so onwards. So therefore, we can work this out, right? So that is 2 plus by a half plus by a quarter, and so onwards. So we know that the ratio, therefore, is equal to a half. So, and the first term is equal to 2. So the ratio is equal to a half. So the sum of infinite number of terms is a over 1 minus the ratio. Sum of infinite number of terms, therefore, is equal to 2 divided by 1 minus a half. And if you type that in your calculator, so it's 2 divided by a half, which is equal to 4. Right, so let's look at question 4. For which values of x will the following geometric series converge? When will this geometric series converge again? It will converge when the ratio is between minus 1 and 1. Okay, so the only thing we need actually to work out in both of these would be to find the ratio. What's the ratio in question A? The ratio there will be 2x plus by 1. How do I find the ratio again? Term 3 divided by term 2, which is the same as term 2 divided by term 1. You can just check, you multiply 2x plus 1 to every single term. In question B, what is the ratio there? Well, there we multiply by 2 minus x every single term. How beautiful is that? Alright, so here we go. So the series will converge. So we said when the ratio is between minus 1 and 1, so it will converge. Ratio is between minus 1 and 1. And what is the ratio in this case? The ratio is equal to 2x plus 1. So therefore, 2x plus by 1 will converge between minus 1 and 1. And then we just need to solve for x. So 2x, how do you get the way of the plus 1? You minus 1 on both sides. So minus 1 on both sides. There we go. And then divide both sides by 2. So therefore, minus 2 divided by 2 is minus 1. And 0 divided by 2 is 0. Alright, and then for the next one, the ratio there is, for question B, the ratio is 2 minus x. It will converge for when r is between minus 1 and 1. So 2 minus x must be greater than minus 1 and less than 1. So therefore, minus 2 on both sides. So therefore, negative 1 minus 2 and 1 minus 2. So negative x should be greater than negative 3 and less than minus 1. And then you just divide every single term by x. What happens to an inequality sign if you divide by negative again? Multiply or divide by negative, what happens? I can't hear you. What happens to it? Yes, you're right. The sign changes. So if you divide by a negative 1 here, so that will become 3, and that will become 1, of course, right? Minus 1 divided by 1 is 1. Minus 3 divided by minus 1 is 3, but remember the signs need to change. We'll get back to that in maths whenever I see you again. We can clarify that. And so therefore, what does this now mean? X is less than 3, x is greater than 1. So that can also, of course, be written as x is greater than 1, x is less than 3. All right. Question 5a, the first term of a geometric series is 124, right? So a is equal to 124. The sum of infinite number of terms is equal to 64. Find the common ratio. So you know the sum of infinite number of terms is a over 1 minus the ratio. You've got a, which is equal to 124, 1 minus the ratio. We don't know what the ratio is, but we do know what the sum is. It's 64. So 124 divided by 1 minus r is equal to 64. How do I solve for r now? Divide by 1 minus r on both sides, right? The denominator, you don't want to do either the variable you want is on the denominator, so multiply it on both sides. So therefore, 1 minus r times by 64 is equal to 124. Therefore, we've got, if you expand that, 64 minus 64r is equal to 124, minus 64r is equal to 124 minus 64, minus 64r is therefore equal to, that's 60, so therefore r is equal to 60 over, so minus 60 over 64. And if you simplify that, you're going to get negative 15 over 16. Right. Let's look now at question B. So for a geometric series with a ratio of 0.22 and the sum of infinite number of terms of 20, find the first term. Same story, sum of infinite number of terms is equal to a over 1 minus the ratio. So we have the answer, it's 20. We don't know what the first term is, so we've got 1 minus 0.22. And then, so therefore 20 is equal to a over 0.78. 0.78 therefore times by 20 is equal to a. What's 0.78 times by 20? So that's 1.56, 15.6, I think. Question 6. In a geometric sequence, the second term is equal to negative 2 over 3. So term 2 is negative 2 over 3. And then the sum of an infinite number of terms is equal to 3 over 5. Find the sequence. Oh hat, what now? Okay, so this is one of those simultaneous equations that you did yesterday. And so we need to just find an equation for each one and then solve them simultaneously. Like they're getting so excited here. So what we've got is the first equation, remember, is the general term. So general term for a geometric series is arn minus 1. So it's negative 2 over 3 is the value of the second term. Let's just switch these people a bit. So then ar, and then it is 2 minus 1. So ar to the 1 is equal to minus 2 over 3. Hopefully that makes sense. You just put this information, that's what you did yesterday, into a general term. Okay, because it's not the sum of the first two terms, the second term is negative 2 over 3. The next part is the sum of infinite number of terms is equal to 3 over 5. Alright, so what is the equation for the sum of infinite number of terms again? Well, a over 1 minus r. So 3 over 5, the sum of infinite number of terms, is equal to a over 1 minus r. So that means you've got two sets of equations. So it's this baby there, a over 1 minus r. And the second one you've got is negative 2 over 3 is equal to ar to the power of 1. Okay, and we need to solve them simultaneously. Alright, so what do we do? So we've got that 3/5 is equal to a over 1 minus r. We multiply 1 minus r on both sides. We've got 3 times 1 minus r over 5 is equal to a. Multiply 5 on both sides. So 3 times by 1 minus r is equal to 5a. So that means that 3 minus 3r is equal to 5a there. Okay, so that just makes that part just look a bit more, I think, a little bit better. I mean, anyway, that's just my opinion. So now what we need to do is, from that first equation, the red one, so we've got negative 2 over 3 is equal to AR. So now you need to decide whether you want A alone or R alone. The power is yours, Captain Planet. Choose wisely. No, it doesn't matter which one. So if I get, so for example, I get A alone, so A is equal to negative 2 over 3R. And I'm going to pluck negative 2 over 3R, that part there, into that A key there. So what we've got is we've got 3 minus 3R is equal to 5A. 3 minus 3R is equal to 5 times by negative 2 over 3R. And what that means is 3 minus 3R is equal to negative 10 over 3R. Okay, fear not. If you get to this stage, you don't want the divide by 3R. So how do you get it away? Yes, I heard you. Yes, you multiply it, but you multiply it every single term. So what we've got is we're going to multiply 3R to 3, and we're going to multiply 3R to that term there, which is also 3R. Hey! And we're going to multiply 3R to negative 10 over 3R. So what do we have? We've got 9R minus 9R squared R is equal to negative 10. What do you think you're going to get here? Yes, a quadratic equation. So 9r squared minus 9r minus 10 is equal to 0. All right, r minus 5 and 3r plus by 2. And so therefore we just solve it. So therefore 3r minus 5 is equal to 0. 3r is equal to 5. R is equal to 5 over 3. Or 3r plus by 2 is equal to 0. 3r is equal to negative 2, r is equal to negative 2/3. Last question. A ball bounces a half of its previous height on each bounce. Find the total distance covered by the ball until it comes to rest if it is dropped from a height of 20 meters. So let's just imagine what's happening. Okay. So it starts off with a height of 20 meters. There's someone standing on a ledge, man on a ledge, dropping a ball, or whoever is on the ledge. Alright, so it will bounce, and then it will go up, but it will only go up to where? Okay, to a height of, what's the next bounce going to be? 10 meters. So it will only go up 10, right? And then what will happen again? Newton tells us the ball will fall down again. Alright, and then what's the next part? It will go up again, but only up to where? Up to 5 meters. This is half the previous height. 5 meters, and then it will go down again, right? And then it will only go up by how much? By 2.5 meters. So then it's 2.5 meters, and then it will go up. And then it will go up, you get the idea. Half of that, in other words, that will be 1.25, right? And 1.25, and so on. Okay, so this ball, we're going to sound like a physicist now, hypothetically speaking, in a vacuum, this ball will keep on just doing that forever, right? Yeah, forever. It will just keep on half. Okay, find the total distance covered by the ball until it comes to a rest if it is dropped from a height of 20 meters. So what do we have? So the first bounce is what? What's the height of the first bounce? The distance covered by the first bounce is therefore going to be that 20 meters, right? It's going to fall 20 meters on the floor, and then it bounces. Yay, it bounces. So then it goes up. What's the next one? It goes up half that distance. So the next distance is going to be 10. It's there now, and Newton tells us, oh, it will go down again. Although some people don't believe that. And then so it goes down 10. And then it will go up half that distance, so it will go up 5, and of course it will go down, so it will travel another 5. And then it will go up that 2.5, and then it will go down the 2.5. And then it will go up the 1.25, you get the idea. And then it will go down the 1.25, so that distance as well. And that just keeps on going forever. Okay, so how do we do this? I mean, you can't to add forever. So what happens here? What do you notice? There's a couple of different sequences here, right? So what we've got is we've got this unusual 2020. It's the only one that doesn't have another partner. So you know it because it gets dropped from height of 20. So we've got 20, and then we've got plus, and then we've got this infinite series, right, of 10, 5, 2.5, 1.25, and so on. And it is double that. So it's twice, okay, the sum of an infinite number of terms. So in other words, 2 times by a over 1 minus r. Does it make sense? So you've got those terms 10 plus by 5 plus by 2.5 plus by 1.25. The sum of infinite number of terms there would be 10 over 1 minus the ratio. The ratio is a half, right? So therefore that will be 10 over 1 minus a half is a half, and 10 divided by half is 20. So it's 2 times by 20. So the sum of 10 plus 5 plus 2.5 plus 1.25 and goes on forever is equal to 20, right? And then, of course, but there's double that. There's another 5. There's another 2.5. What goes up must come down. Oh, well, yeah. So because the first one is going up part. Okay, so what do we have there for? We've got 20 plus by 40, and 20 plus by 40 is 60 meters. So even this ball will bounce forever and ever. The maximum distance, total distance covered of that ball will be 60 meters.